What is the most used man-made material on Earth? You guessed it, it's concrete. Look around, it's everywhere. You see it in sidewalks, driveways, foundations, floors you stand on, and even entire structural building frames are made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. Welcome to the Concrete Logic podcast. Today I got two guests, Jessica Wilson and Doug Clark from CarbonCure. Thank you all for joining me today. Jessica, do you want to give a little bit about yourself and about CarbonCure?
Sure, absolutely. Thank you, Seth, for having us. It's a pleasure to be here. My name is Jessica Wilson, and I serve as the East Coast Marketing Manager for CarbonCure Technologies, and I'm based in Wilmington, North Carolina. And my essential role for CarbonCure, who is a clean tech company based out of Canada that specializes in a myriad of carbon technologies, carbon sequestration technologies. We're based in Halifax, Nova Scotia. And we'll talk specifically today about our CO2 injection process. But my main role as market development manager is to partner with our producers to deploy low embodied carbon concrete to the communities that they pour concrete in. So I'll let Doug introduce himself.
Yeah, hi, I'm Doug Clark. I am the East Coast Sales Director for CarbonCure Technologies, and I work directly with the producers. We started strictly in the ready mix business, and we've expanded that into precast, and we do a little bit in masonry as well. But like I said, I sell it directly to the producers, and then work through the process with them. And Jessica and I work very closely with our customers in many phases. Market development, promotion of our technology, and implementation. So it's a good team effort.
Sounds good. So Jessica, do you want to just kind of, like I shared with you before we started this, is I'm ignorant of CarbonCure. It's a new technology, right? And I think some folks have been using it for a little while, but I have never used it myself. So could you, I guess, tell us what it is?
Yeah, so essentially, CarbonCure Technologies developed a system where we can take CO2 from large industrial emitters such as fertilizer plants, manufacturing facilities, take that purified CO2, and then inject it into concrete as it's being batched on site at producer partner plants so that they can reduce their cementitious content, but also reduce their carbon footprint. And the beautiful thing about CarbonCure is that you can deliver the same quality concrete to your project sites with a lower embodied carbon footprint. And so it doesn't impact any of the fresh and hardened properties of concrete. You're getting the same product at the end of the day, but with a lower carbon footprint. And I can walk you like the nuts and bolts. If you want the details around it, we can do that too.
As a concrete guy, definitely. Okay. But before we go into, I guess, those type of details, as far as the process to inject CO2 and the setup of CarbonCure system at a ready mix facility, can you kind of run us through that? Is there any, any changes that we would see as a concrete contractor on our end? Could you kind of give us an overview of that first?
Yeah, absolutely. So I guess we'll start with CO2 supply, because that's usually the many questions that I get around our technology is around, where does your CO2 come from? Do you create it? Do you capture it? Where does it come from? And so let's start with point source in terms of supply of CO2. So fun fact, before I joined the CarbonCure team, I had no idea that the same CO2 that we're leveraging as a clean tech company was predominantly sourced and used by the carbonated beverage industry. So basically, these large gas suppliers like Praxair, Air Liquide, Airgas, they have long worked with large industrial emitters to purify and collect their CO2 from, capped sources essentially. And so that CO2 has again been predominantly the source for CO2 for the carbonated beverage industry. So anytime you've had a seltzer or a beer for that matter, that CO2 is purified industrial grade CO2. So that's fun. But nonetheless, we're tapping into that existing supply chain and working with those gas suppliers to deliver CO2 to our producer partner sites. And once that CO2 is on site at both a fixed and or a portable plant location, it is stored in a stainless steel cylinder. So it's about 8 foot tall, and it's stored right on site and near your batching facility. And with regards to our technology, that CO2 is injected into concrete as it's being batched, just like an admixture. So essentially, we have a team of engineers that will come onto our producer partner plant site, work with them hand in hand to optimize their mixes, which from a concrete perspective, essentially, I always have to typically define the difference between concrete and cement to any given audience. Usually, there's a gross misconception that cement and concrete are the same thing. But for those in the audience today that don't know the difference, cement is the main binding ingredient in concrete, right? And so on any given concrete batching site, you'll have a truck that pulls up usually, and they're batching both the dry and wet ingredients. And dependent on the type of plant that you have will depend on the sequencing of when CO2 is injected. But nonetheless, it's usually at the very end of the process because the CO2 needs to react with both water and cement to appropriately turn into limestone. So with regards to your first question about concrete contractors, though, as to whether or not it makes a difference for you all when you're procuring sustainable concrete and delivering it to site, it does not. Like essentially, once that CO2 is injected into concrete as it's being batched and then delivered to your site, instantaneously a chemical reaction is occurring where that CO2 converts into limestone, and that's a mineral. And that's where we get compressive strength benefits arising from injecting CO2 into the concrete. So at the end of the day, your boots on the ground, if you were to have 2 trucks pull up on site, one with CarbonCure and one without, and do a blind test, your finishing properties are the same. You would not know the difference.
Huh.
Yep.
So I guess what problem was CarbonCure solving? Why was it created?
Yeah, so that's a great question. And I came from U.S. Green Building Council, and we are always promoting sustainable building design and, high performing buildings. But rarely, with regards to materials transparency, did we talk about the sheer omnipresence of concrete in our communities. So what blew my mind when I joined the CarbonCure team was to learn that, in terms of the global CO2 impact of the concrete industry, approximately 7% of the world's total CO2 emissions are from cement manufacturing. And so approximately for every 1 ton of cement that's manufactured, roughly a ton of CO2 is emitted into the atmosphere. It's 0.922 to be exact, but nonetheless, that's an incredible carbon footprint associated with the concrete industry. So as there has been a global demand to draw down carbon from our atmosphere, of course, concrete was a culprit, right? The industry started gaining a lot of attention with regards to its carbon impact. And so collectively as an industry, we needed to make a change. And that's where CarbonCure Technologies became one tool in a suite of tools with regards to trying to achieve net zero embodied carbon and carbon impact of concrete. We're getting there. We're not there yet.
Okay, so it's one of the tools to offset our carbon footprint as a concrete producer or contractor. Is that correct?
Absolutely.
I gotcha. So we're just utilizing CO2 that's already out there, that's being, like you mentioned before, used by the beverage industry mostly, it sounds like. But are we capturing, I would guess I would call it dirty CO2? Are we capturing any dirty CO2 yet and injecting that into concrete?
That's ideal. And we are certainly exploring pathways to even do direct air capture with regards to CO2. I mean, technology is being, as we speak, essentially developed to take atmospheric CO2 and utilize that as a CO2 supply. But nonetheless, again, that technology is underway. So that's why we're tapping in to that existing CO2 supply. To use it in concrete, in terms of the purification that I mentioned earlier, we don't really need to purify it to that food grade state. So ideally, we could further reduce the entire life cycle carbon impacts of the entire industry and process associated with CarbonCure by using quote dirty CO2 as you mentioned. That would be ideal, and that's where we're heading in terms of the future.
I got you. So you mentioned that there's no noticeable difference between just normal concrete and concrete with CarbonCure in it. So how do we know how much CarbonCure is actually in the concrete? How is that measured as you're injecting it? Are you able to take, say, like a core of concrete after it's cured and see the CO2 in the concrete itself?
Yeah, so we measure the CO2 that's being dosed at every producer partner plant. And we do that because we want to obviously communicate their carbon savings for every truck that's being delivered. So, with that being said, our technology and the producer partner batching software systems communicate directly with us. So, we're able to say exactly how many tons of CO2 was again injected into the concrete, as well as how many acres of, say, trees that's equivalent to absorbing CO2 for a year. So we have many metrics that we can quantify the CO2 savings associated with CarbonCure and injecting that into the concrete. Now, with regard to core samples, Doug, if you want to interject your experience here working on site, that would be great.
Yeah, I mean, even under a microscope, you really can't tell whether it's in there or not. I mean, once again, we go back to the batch records. We know it's in there. We see the improved compressive strengths, but to actually verify it, it's very tough in the actual, concrete, say, core.
Okay, so it'd just be on a batch ticket, just like every other aggregate or sand or cement that's batched on that truck.
Correct.
Okay. And then as far as what else did I want? So it's injected in there. Oh, the question regarding, you mentioned, Jessica, offsetting the amount of cement that we're putting in each batch. Can you go back to that? Is there a formula there, or how's that work?
Yeah, so, as you know, working in the concrete sector, concrete is heavily influenced and dependent on regional materials. So I like to start off the conversation by saying, we have to work with our team of engineers, with producers to optimize their mixes dependent on their location and dependent on how much cementitious content is already in there to begin with. So sometimes you have heavy mixes versus lean mixes, etc. But nonetheless, essentially, if you wanted to do back of the napkin math around carbon savings and cement reductions, it's usually safe to assume that with CarbonCure technologies, we can save about 4 to 6% with regards to cementitious content. Okay. And so that's usually equates to about 20 to 35 pounds of CO2 per cubic yard of CarbonCure concrete poured. And so, with that being said, again, we have to get the 28-day break data before we ever deliver any type of concrete to a job site with CarbonCure to ensure that compressive strength and performance standards are not being compromised. And so, that's the gist of how much cement you can pretty much reduce. And I assume, I don't know, but the next question might be around cost. So that's usually
Before we get to that, so it sounds like just like a normal job, we would do trial batches, get compressive strengths at 7, 14, 28 days. You do the same thing with CarbonCure. That's not changing anything. And so how are y'all getting specified? Like, is how are engineers and architects, are they acceptable to this? I'm sure there's a lot of folks that are, but I guess for someone that has a project and never heard of this technology, how would they convince an engineer to include this?
That is the question of the day, and I mean that wholeheartedly. So my main role is to not only work with our producer partners to elevate their sustainability narrative around carbon reduction, but the other half of my job is influencing the AEC community to modify specifications to really create industry change around the type of concrete we deliver to job sites. So to your question about, if someone's never heard of CarbonCure, how are they going to specify it? Well, that's the big conflict right now. It's the big awareness gap existing in the structural engineer and architectural community, as well as the general contracting community, that CarbonCure is available where they are. So I get out literally on the ground and I perform lunch and learns and all types of educational sessions around how best to specify CarbonCure. Essentially, we're calling for modification of specs, essentially to move from very prescriptive, rigid-based specifications to performance-based specifications. So specifying strength, really eliminating any type of minimum cement requirements, because obviously we're trying to reduce cement in our case. Also, with regards to SCMs, CarbonCure is compatible with supplementary cementitious materials. So fly ash, pozzolan, slag, etc. We can be added and compounded to the entire really set of ingredients within a concrete mix to reduce embodied carbon. So it really just depends on the engineering or architectural firm as to their willingness to modify specifications. But once they learn about CarbonCure and once they truly understand the entire carbon impact of the cement industry as a whole, typically they are excited that this technology exists. They're looking for solutions to reduce their carbon footprint. It's just people don't know what they don't know. And so right now, the big, I'd say, barrier to rapid market transformation from a low embodied carbon concrete standpoint is just awareness. It's getting out there and letting people know that we exist as a technology. You're not a guinea pig. We've been poured in over 14 million cubic yards of concrete. We've partnered with over 500 producers to date. We're globally expanding. We're here. We've been in your communities. Sometimes I would likely safely bet that you have poured CarbonCure. You might have CarbonCure on one of your projects and you don't even know it, So, but we need that market demand and market signals around specs to say that low embodied carbon concrete will be the norm. It will be best business and project practice moving forward.
Gotcha. And so you were jumping to one of my questions as far as the cost. It sounds like ideally the CO2 offsets some cement use. Mm-hmm. So I like to beat up on concrete producers on price. So,
right.
So I shouldn't see any increase, right? And no increase, maybe even a decrease since we're using less cement.
Good one. No, you won't see a decrease. No.
Nice try.
No, I mean, so here's the deal, right? It was very intentionally made with regards to a value proposition for producer partners by our leadership team to have a balanced ROI for them so that we could have rapid, again, deployment of low embodied carbon concrete. We are mission driven. So at the end of the day, we want to reduce carbon. And so how do we do that from a sound business perspective? We create a value proposition for our producer partners that allow them to reduce cement, which, as you know, is one of the most expensive ingredients in concrete. It's also the most carbon intense. But they also have to pay for a licensing fee for CarbonCure technologies and, of course, the CO2 contract. So that all balances itself out typically. And so that's why we have producer partners being able to deliver CarbonCure concrete to their respective communities at a very small, if any, green premium. And so oftentimes our producer partners will deliver it at cost compared to, a typical load of concrete. And or sometimes we see a maximum of a 1 to 2% increase per cubic yard, which from a project perspective, it's basically a rounding error. So that's why we've been so successful with regards to industry transformation and a technology company as a whole.
Mm-hmm.
Yeah.
So it's a value that you're providing, and hopefully not at an increased cost.
That's right.
Right. I got you. Yeah, because like you mentioned, the utilizing concrete as a structural frame or a component of the buildings has been getting a bad rap lately because of the cement use and cement's carbon footprint. So we need whatever we can use as a tool or to show the benefits of using concrete versus, I won't even say the other things, but because I hear it all the time. So mass timber and steel and all that, and you start digging into those things, and you're like, are they really that environmentally more friendly than concrete? So I think if you compare them, it's not the case.
Well, and I think, it all depends, right? Like from a architectural vision perspective, what type of material someone wants to use, or, in terms of its resilience or strength. But at the end of the day, I mean, CarbonCure has been able to provide a legitimate solution to, like you said, kind of curb some of the environmental bad rap that concrete has had historically in the past, and there will be other solutions as well to get us closer to, again, net zero. But nonetheless, there's only so many avenues that you can take. You always have to use concrete, right? Like concrete will continue to be one of the most consumed resources on the planet. And as we move into very unpredictable climate circumstances, concrete, in terms of its resilience, its durability, its affordability, its use in ICF structures, it's still going to be rapidly used. And I don't know if you've heard this, but over the next 40 years, our built environment stock is going to dramatically increase. And so that's going to be a good thing for the concrete industry. But to put things in perspective, we're building an entire New York City every month for the next 40 years. And so concrete will be deployed at scale. But how do we, again, reduce that environmental and embodied carbon impact? So from a life cycle assessment perspective, with regards to other materials, again, concrete and steel are usually neck and neck in terms of embodied carbon. Mass timber is incorporated in many projects as an embodied carbon solution, but concrete's not going anywhere.
Yeah, I mean, we've been literally using it for what, thousands of years. So
yeah,
it's
right?
It's a material that's used quite frequently. As far as is there anything else that we didn't cover that you think is important for us to know about CarbonCure?
I would say the one thing to add would be the life cycle assessment piece, because oftentimes I get confronted with that. That's a very common question with regards to, okay, well, there's carbon associated with transporting and purifying CO2. Do the benefits outweigh the carbon cost of the technology? And I just want to, let everyone know that we've done a full verified life cycle assessment on our technology, and the benefits do outweigh the carbon impacts associated with any type of, CO2 purification or transportation. And that's becoming a really big focus area for architects and engineers, is looking at EPDs as well as, again, that LCA of any given material with regards to carbon associated with the scope 3 emissions. Okay, so I just wanted to share that with anybody that may have questions around life cycle assessment, because I get that a lot. But no, thank you, Seth. And ideally, again, this will become best building practice with regards to low embodied carbon concrete. That's the hope at the end of the day, is that we have market transformation. So
yeah, I appreciate you and Doug coming on the show today. Jessica, if someone wants to reach out to you, what's the best way to get a hold of you?
Sure. You can email me directly at jwilson@carboncure.com. And I am always available also by phone. So if you get any viewers today that want to contact me, Seth, feel free to, give them my number. It's fine.
All right. And Doug?
dclark@carboncure.com. I'm here in Richmond, Virginia. And, CarbonCure is available in most of the major cities on the East Coast. So we're in New York, Philly, DC, Baltimore, Richmond, through the Carolinas, Atlanta. So we're out and about.
Yeah, I think as CarbonCure becomes the norm, I think we'll have more questions and talk about more about how it can offset cement. I think that's going to be very important down the road, especially what we're going through. So with the shortages and things like that we're confronting. But again, thank you for coming on the show, Jessica and Doug, and hope to talk to you guys soon.
Thank you, Seth. We appreciate you.
Thanks, Seth.
Hey, everyone. I hope you enjoyed today's episode of Concrete Logic Podcast. If you did enjoy, please hit subscribe on your favorite podcast listening app and share with others that you would think would find value in the podcast. I look forward to having more discussions. Please tune in, and we'll see you on the next episode of Concrete Logic Podcast.